Here we have a calculus problem on finding critical numbers for a function. There is a function given over here, and we have to find critical numbers for this function. Okay, whenever I want to find critical numbers for a function, what I need to do is I have to find the first derivative of the given function, and it has to be equated to 0 and solve for x. Okay, now let me write the given function as it is. It is f of x equals to x positive 1 over x square positive x positive 1. Okay, so here this function contains a variable in both numerator and denominator. So whenever I want to find the derivative of a function which contains variable in both numerator and denominator, I have to use the quotient rule of derivative. So what is the quotient rule of derivative? Okay, now let's consider the division of u and v, and here we have to assume both u and v are variables, and I want to find derivative of this fraction u over v. So for that, what I need to do is first I have to square the denominator v, then I'm getting v square. The same v should be taken over here. Now I have to get the derivative of the numerator, that is u prime. Now I have to take negative sign. Now I have to keep the numerator u as it is, and I have to get the derivative of the denominator v, then it will be v prime. So this is called quotient rule of derivative. So the same thing I'm going to do in our problem. So that is f prime of x equals to, so first thing what I need to do is I have to square the denominator over here. Then I'm getting x square positive x positive 1, the whole square. Now I have to keep the denominator x square positive x positive 1 as it is, and I have to get the derivative of the numerator, that is x positive 1 prime. Now I have to take negative sign. I have to keep the numerator x positive 1 as it is, and I have to get the derivative of the denominator, which is x square positive x positive 1 prime. Okay, now let me continue the next step. F prime of x equals to, so now I have to write this term as it is, that is x square positive x positive 1. Okay, now we have to get the derivative of this x positive 1 with respect to x. So actually 1 is a constant. When I find derivative of this 1 over here, it will become 0. So the derivative of this x with respect to x, it will become 1. Negative x positive 1 times. Okay, now I have to get the derivative of this expression. So when I find the derivative of this x square, it will be 2x, and when I find the derivative of this x, it will become 1, and this derivative of this 1 will become 0. Everything has to be divided by x square positive x positive 1, the whole square. Okay, now let me continue over here. F prime of x equals to, when I multiply this one by 1, the same, that is x square positive x positive 1 negative. Okay, now let's multiply these two binomials, and then we can distribute this negative sign to the result of the product of the two binomials over here. Okay, first let me distribute, we can use FOIL method, that is we have to multiply the first terms and then outer terms, inner terms, last term. So when I multiply the first terms x and 2x, I'm getting 2x square. Now I have to multiply the outer terms, that is x and 1, then I'm getting x times 1 is positive x. Now inner terms, 1 times 2x is 2x. Now let's multiply the last terms. 1 times 1 is just positive 1 over, so the denominator is x square positive x positive 1, the whole square. Okay, so f prime of x equals to, now let's simplify the stuff in numerator. That is x square positive x positive 1 negative, so 2x square. When I combine this x and 2x, I'm getting positive 3x positive 1 over x square positive x positive 1, the whole square. Okay, now let's do the some more simplification. F prime of x equals to x square positive x positive 1. Okay, now what we can do is we can distribute this negative sign to this 2x square. Then I'm getting negative 2x square. Negative times positive becomes negative 3x. Negative times positive will become negative 1 over x square positive x positive 1, the whole square. Okay, now also this positive one, negative 1 will cancel out. I'm getting f prime of x equals to, so when I combine this x square and negative 2x square, I'm getting negative x square. And when I combine this positive x and negative 3x, I'm getting negative 2x over x square positive x positive 1, the whole square. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, that's all the simplification we can do in the first derivative. So now what we can do is we can equate the first derivative f prime of x to 0 and solve for x to get the critical numbers. Okay, when I equate f prime of x to 0, I'm getting negative x square negative 2x over x square positive x positive 1, the whole square equals to 0. Okay, now I have to get the denominator over here. For that, I have to multiply both sides by x square positive x positive 1, the whole square. On the right side also I multiply by x square positive x positive 1, the whole square. Then this one will cancel out. I am getting negative x square, negative 2x equals to, so 0 times everything will become 0. Now I can factor negative x from this expression on the left side. If I factor negative x out, then inside the parenthesis I'm getting x positive 2 then equals to 0. So if I distribute this negative x to x, I'm getting negative x square. When I distribute this negative x to 2, I'm getting negative 2x. So the factoring what I've done is correct. So here the product of these two quantities equals to 0. Either the first quantity, that is negative x equals to 0, or the second quantity x positive 2 equals to 0. If negative x equals to 0, then x also must be 0. That is, when I multiply both sides by negative 1, I'm getting the negative x will become positive x, and when I multiply 0 by negative 1, it will still be 0. Okay, now let's solve for x in this equation. So for that, I subtract 2 from both sides. When I do so, positive to negative will cancel. I'm getting x equals to negative 2. So I'm getting two values for x. One is negative 2 and the other one is 0. So these two values are called critical numbers. So because I got these values for x by equating the first derivative to 0. So the values we get for x by equating the first derivative, that is f prime of x to 0, are called critical numbers. Okay, so only these two values are critical numbers, or is there any other value? So we cannot decide immediately only these two values are critical numbers. Apart from that, we have to do one more check. That is, we have to go to the final step of the first derivative, that is in this step. So in this step, we have to check whether this f prime of x becomes undefined for any real value of x. So here it's a rational function because we have variable in denominator. So if the denominator is 0, then the value of this fraction becomes undefined. That is, f prime of x becomes undefined. So we have to check whether there is any real value of x which makes this part, the denominator part, 0. So how do we have to find the real value of x which makes this denominator part 0? So for that, what I need to do is I have to equate the expression we have in denominator to 0 and solve for x. Okay, let me do it over here. X square positive x positive 1 the whole square equals to 0. Okay, to solve this equation for x, first I have to get out the square. For that, I have to take square root on both sides. When I take square root on both sides, the square root and square will cancel out. I'm getting x square positive x positive 1 on the left side. On the right side, square root of 0 is 0. Okay, now how can we solve this one? This is actually a quadratic equation. So we can solve this quadratic equation either by factoring or quadratic formula. I think first we can check the value of the discriminant, because from the value of the discriminant we can find whether there is any real value of x for which this expression is equal to 0. That is, we have any real solution for this quadratic equation. So what is the discriminant of a quadratic equation? That's something but b square negative 4ac. So for that, we have to compare this quadratic equation with ax square positive bx positive c equals to 0. So when I do such comparison, so what value do I get for b? So b is the coefficient of x. So what's the coefficient of x in this equation? It's just 1. So we can plug in 1 for b, that is 1 square negative 4 times. What's the value of a? A is the coefficient of x square. In our equation, what's the coefficient of x square? It's 1. So 4 times 1. So the c is a constant term. It's 1. So I'm getting 1 square is 1, negative 4 times 1, negative 4 times 1 is 4, again 4 times 1 is 4, I'm getting negative 4. So finally I'm getting negative 3. That is the value of the discriminant b square negative 4ac equals to negative 3. So whenever the value of the discriminant b square negative 4ac is less than 0, then the quadratic equation over here has no real solution. That means no real value of x will make this expression 0. So the denominator over here will never become 0 for any real value of x. So f prime of x will not become undefined for any real value of x. So negative 2 and 0 are the only two critical numbers. In case here we have a question. So what if there is some real value of x for which the denominator becomes 0? Then f prime of x will become undefined. So if there is any real value of x for which f prime of x becomes undefined, so that value of x also should be considered as critical number. But here we don't have any real number which makes the denominator 0. That means which makes f prime of x undefined. So the values we got for x by equating the first derivative to 0 are considered to be critical numbers. So the critical numbers for the given function are negative 2 and 0.